Okay, we're back out here to the drill yard with Squad 1, and in a previous video we talked about limiting factors of pumping, and whether you're on the booster tank, your 500 gallons a minute, and what your rating plate means. And the rating plate on this one is 1,250 US gallons a minute, so it's a 1250 pump. And people think that, oh, they got a 1250 pump, they can pump lots of water. But the limiting factor, apart from your plumbing lay, is really your compound gauge. And I promised a video 3 years ago that was called All About the Compound, and that's what it is. As a engineer or pump operator, you are throttling and throttling and throttling to bring your compound gauge. In the United States, they would call this the inlet pressure. We call it the compound because it also shows a vacuum when you're drafting. But basically, we bring our inlet pressure down to 20 psi, and that ensures a bit of a positive pressure in here, and it ensures public safety in the water supply system. So I've been struggling to think how I can talk about the squad and how the limiting factors work. And everybody learns differently, so we'll just try it this way. This is a graph. On this side of the graph, we have PSI as it rises up. And on this side, we've got gallons per minute, GPM, and it rises that way. So your standard water supply system, if your hydrant's not flowing, it might have, say, 60 PSI with no flow. And then as we challenge the water supply system and we start taking water out of the hydrant, we might get to, say, 1,000 gallons a minute, but the system in the ground only has 20 psi left. So we plot 20 here, so 20 would be there, 1,000 gallons a minute, there we are, 60 at 0, and we get this theoretical line as the municipal system decays. And this is just an example. Water supplies are all over the place. So our challenge is to get a lay that gives us 20 psi at the truck and eliminates, or can't eliminate, sort of minimizes the friction loss to the rig. If we had, so 1,250 gallons a minute as our target, as I said, you got a lot of work to do before you get that 1,250, and it doesn't matter whether you got a 2250 pump or an 840 pump or a 500 pump, you got the same amount of work to do. So if we have 100 feet of 4-inch hose, that's going to give us 1,250 GPM, 100 feet of 4-inch hose on the inlet to the truck. That's going to give us 30 psi of friction loss. So 30 psi plus the 20 residual we need gives us 50. So that's way over here somewhere. That's outside the line. We're not going to get it out of any hydrant. Some of our hydrants in Brentwood only start at 50 psi. So it's about understanding your municipal water system, how much water they got in the ground, how you're going to get it to the rig. So if you've got 50 static here and it goes down like that, you're not doing anything with 100 feet of 4-inch. If we take that same 1,250 psi that we're shooting for with the squad and we put it through 25 feet of 5-inch, cameraman, what do you think the friction loss would be?
4.
Oh, geez, you're so close. 3. So we're down to like 1/10 of the friction loss. So now if we have 23 psi at the hydrant, we could theoretically still get this kind of flow. So what we need to do is we need to maximize our lays. The one other thing they taught you in aerial strategies and tactics is CIA 5-3. And I don't know how that means anything, but commercial, industrial, apartments, more than 500 gallons a minute, more than 300 feet, you should consider relay pumping. So this squad has 9 outlets, 9 2.5 outlets, a couple of 1.5 inch outlets, It just has tons of capacity if it's the first rig in, and we're in a really good spot that if the second rig in is one of our engines, they have big pumps they need to hook on and feed the squad in order to do it. And the way we're going to do that, clearly if you do 100 feet of 4-inch, you know, if you only need 500 gallons a minute, you're good. But if you need 1250 or 2000 or more and you want to maximize your thing, you want to have, this is a 25-foot piece of 5-inch, 3 inches of friction loss there, and we also feed the truck with a second line of 4-inch around the other side, because the trucks typically only carry one piece of 5-inch. So this is our hydrant lay on our engine to feed the squad in its relay pumping. CIA 53, understand your water supply systems. Your graph from Keating and Brentwood are going to be extremely different, but all things equal, if we're going to relay pump, we need to minimize the friction loss from the municipal system to the truck. We need to get every liter per second of water out of the municipal system. Questions? Life is good.